Hello and welcome to As the CMMC Churns. I'm Matt Titcomb, the CEO of Peak InfoSec, an authorized CMMC third-party assessor organization. I'm also a CMMC certified practitioner and provisional assessor. Today's episode is the 3 Descoping methods. Sorry, we're not going to sound like the count in this. So in doing this, we need to first recognize the different component types that come out of NIST SP 800-171, paragraph 1.1. Shocker, coming from me. So the first ones are always those components that process, store, transmit CUI. Components then that provide security protection for CUI components are the two main ones we normally talk about. Those are going to be the ones in scope. That second definition actually has a reality to it. So it's really those components that protect CUI and other components. They do other stuff too. And we need to recognize that because that becomes critical, because in reality, that's the third group of components, those that don't store, process, or transmit CUI, but do depend upon the security protection components. Now, when it comes down to it, there is a fourth category here of components. Those are the components that don't process, store, or transmit CUI, or depend on the security protection components. Okay, so what do we do with these four? Well, the fundamental plan here is to basically take those two bottom ones and shove them two out of scope. And that's what we're going to talk about today is how do we start to move things out of scope and keep you as your scope as small as simple as possible so you can still do your job. So let's talk first about those indirectly related components. Again, that's the ones that don't process, store, transmit CUI or depend on security protection components. So good examples of this classic one is your public-facing website, a background check system, your phishing exercise system, the government security hub where you get your CUI training at. These are all things that are critical to the way you may operate as a business, but by definition are out of scope. Now you've hit our very first one here, definition. So we need to recognize that this is actually your first scoping method. If it doesn't fit, you can take it out of scope. Now, the way you handle this is you identified in your system security plan, this component does not process, store, transmit CUI, or depend on other security protection components. You do need to explain its function and how it may be used in support of an in-scope procedure, i.e. that background check is going to be used in support of the onboarding process. It's really the result of the background check that matters, not the background check system. If it's non-applicable, state so. So again, this is the first descoping method you need to be aware of. Now, for those that are related components, this is where the other two come into play. Again, these are the ones that but do depend upon the security protection components. Example list, guest wireless, integrated single sign-on applications, your learning management systems tied to your Active Directory, etc. Now, these are out of scope by the isolation techniques. Now, you do need to explain this all in your system security plan because there is a connection, and these are considered external information systems, but you're descoping them. Now, in this case, you need to explain the isolation techniques, and you need to explain its function and how the isolation technique functions to keep it out of scope. So let's go through some examples here. So let's talk first in the isolation techniques. We're going to talk about physical separation. It's the first main one we talk about in here. So physical examples are a safe. You keep things in a safe. So you were able to shrink your scope down to miraculously, never happens, down to a single laptop that contains CUI. Got it. This is exactly the same way we handle classified laptops for clients that have classified information in their business. In this case, it's in a GSA approved safe. It's kept in there. You have to register every time you open it up, use the system. When you're done, put it away. Great. You can do the same thing with physical media, etc. So again, that's a physical isolation technique that nobody can get in that safe unless you're authorized. trained and you know how to open that combination. And GSA combinations are very finicky, so good luck with that. Other one is going to be isolated processing areas. So we've got on the left, we've got an office space that's isolated from everything else. People in there can be working on CUI, discussing CUI. And then on the production floor, you've got two areas there that are actually involved in storing CUI and or making things and doing things with CUI. Again, to do this properly, you would have to physically isolate those areas. Typically, that's going to be done via something like an RFID badge scanner. Only people can get in. Now, other thing you would do is you'd put, like in that production area, a chain link fence around it that would go up high enough that somebody cannot just easily climb over a little 4-foot chain link fence. That does not work. And you also need to put enough visual blockades in there that somebody walking around the building doing their normal work can't go in. Now, how do you handle this? Again, you need to explain the processes used to keep isolation effective when you're using physical isolation techniques. So again, there's a lot of ways to apply this in your business, and this is where DoD and really NIST has kept scoping kind of open because it's appropriate to allow you the flexibility based on your business to adapt how you can best do this. So logical isolation, our first one we always hit up here is network, because we do talk about employ logical, meaning firewalls and other boundaries, subnetworks. Well, we got to have a conversation about what that really means, because a lot of people think if I just do subnetworks, I'm good. No. So the classic thing we walk into in a business, especially when we're just starting out with them, we see they've got a firewall, but they've basically got everybody on a flat network. Sometimes it's all just on one side and everything's commingled, and occasionally they've been smart, they've moved it out. In this case, we've got a router in the middle, and in reality, all a router does is route. So this is actually going to be a fail. Why? Because fundamentally, the firewall is protecting and monitoring communications from the internet. You've designated internally an internal boundary between those two scopes, but you have no protection controls in the middle. Yes, you can set a router up to restrict communications. That's control, not protect. Now, likewise, so it's controlling this traffic. It is not implementing those core requirements. And then there's a whole slew that you can go off of those as you get more into the dependencies. So in reality, when I come in as a network engineer and doing this for large companies like Sony, this is in reality a routed flat network. It's not going to really protect you. So the right answer, though, is now we move that firewall, whether it's that same one or you've got an internal firewall. That's, again, architectural design discussions you can have. But in reality, that firewall could allow the CUI VLAN to communicate to the out of scope. We do this a lot with enclave models because that out of scope is considered external. Now, likewise, that out of scope cannot get into the CUI VLAN. All communications are blocked, it's monitored, it's protected, IDS, IPS is running, etc. on that firewall. This is a successful architecture. This is in turn fulfilling all of the primary architectural and security requirements around the way you would set up your network. Now, this is also properly segmented. It's a very simple model, but this is the properly segmented at the simplest level you can do. Now, this is also the foundational start to zero trust design for your architecture as you go forward. So likewise, as we move on, there we go, we need to talk about access control isolation. So let's take our current model and we're going to make it a little bit more complicated. We are now going to add a server VLAN. And in that server VLAN, we've now got Active Directory. We've now got a file server that is storing content. It's all in the same server. But on that file server now, we've got different folders. One folder's for our CUI content and another folder's for non-CUI content. Great. In this approach, so the file server and Active Directory are fulfilling and limiting access to the environment. Again, you need to restrict communications to that file server to just the known devices that should have access, and then the file server's access control permissions based on folder permissions are controlling and fulfilling 311 fundamentally. Now then, the firewall is still doing the network stuff, and this is a properly segmented architecture. Zero trust as a foundation starts at a very simple, typical zone-to-zone type communications. But as you get more and more mature in zero trust, you move from zone to zone to IP, and then eventually IP to IP. And then you get really crazy. You go IP to IP based on person and or role, etc. So that's the way you approach a mature architecture as you grow into zero trust. Now, this is successful the way it is right now because only people in the CUI VLAN have access to CUI content. Unfortunately, what we find all too often is when we start digging into this, we find people from the non-CUI VLAN having access. That is now a fail. Again, your access control mechanism has failed at this point in time. Now, the way you use this, file shares, SharePoint teams, application level control, etc. This is a pretty common architecture we run into in businesses. Now, there is the hybrid technique, that combination of both. In this case, it's both physical and logical. So let's talk about that same kind of basic architecture, but now we've got a remote user coming in. They're coming in from an unauthorized device, meaning it's not managed, but they have a need to get to content internally. This is a classic use case we see with MSPs, with people that are contracted in, but their company's never going to become compliant. This is a mechanism you can use to do this. So in this case, the remote user comes in, they go to the remote user VLAN, hint, hint, wink, wink, nudge, nudge. That's the right way you handle remote users. You never drop them in to the CUI VLAN or out of scope. They always go to a separate VLAN. From there, that remote user, based on, again, zero trust, can only go, oh, hey, Chuck can only RDP to a jump host. Great. From that jump host in a separate VLAN, again, we are controlling what Chuck is trying to do as an unauthorized user, and we're isolating his device. I keep it out of scope from that jump host. Now, Chuck, as that remote user, can get to the CUI VLAN, do what they need to do. Or if you're really crazy, like I had to deal with when I was working with Sony, from that jump host, I had to jump to another jump host to do the real work I need to do. Again, wrapping layers of isolation. Again, this would be a successful architecture. Now, this fails if the remote user can print locally, because the moment I can print locally, I'm printing CUI locally, and it's out of scope. PDF files, etc., all now start to kick in. You can download files, or you can copy and paste out. I can't stop somebody from taking a photo with their camera. That's got to be in your risk registry as an accepted risk. Now, again, this is a common use we see with virtual desktops, and there's a lot of variants. You can start and get very creative with this combination. So let's sum up kind of at the high level here. There really are three ways to descope components from your environment. Don't forget the by definition method. This is actually sometimes your most powerful method, especially for those things that are secondary that may just be supporting your processes, but they're really not involved. Leverage the physical, logical, and both techniques to keep your components out of scope, and then document everything in your SSP. Now, likewise, as we get into this, that red line going all the way back in the previous diagram where we talked about the components, be ready for negative testing of isolation techniques. For example, guest wireless. I will look to see if there is a deny all rule for anything from the guest to try and get in, that it is blocked. Again, that would be an appropriate test and a negative testing of your isolation techniques. So next week, we're going to talk about implementing CMMC, and we're going to bust that myth wide open. And again, I'm Matt Titcomb from Peak InfoSec. Thanks for joining us today for the CMMC Churns.